Hello students, in this video we are going to learn recapitulation of S&P block elements. The 3 sessions allotted here. Now I'm going to change over to the PowerPoint mode. You can have a look at the PowerPoint. 3 sessions have been allotted to this chapter, out of which this is the first session. This comes under Tumkur University jurisdiction. This is for the first year BSc students. After watching this video, the students will be able to understand few things like modern periodic law, periodicity in S&P block elements with respect to their electronic configuration, and we'll also learn definitions of few important periodic properties like atomic radii, atomic and ionic sizes. Before going into the details of this particular video, let us have a recap about a few things. You must be remembering that last year was declared as International Year of Periodic Table, and this was a tribute to the periodic table because chemistry plays an important role in periodic table. Mendeleev and Moseley have contributed towards this periodic table. Mendeleev was the first person to take up the separation or arrangement of elements into different groups and what we call as periods. Later on, Moseley he was able to divide the elements into different groups and periods. This division of elements depends upon the atomic number, and all the elements have been divided into SPD and F block elements. And later on, we'll also know a few things about the periodic properties. Let us first go to the modern periodic law. It states that the physical and the chemical properties of the elements are periodic functions of the atomic numbers. And a bit about periodicity, it is the occurrence of repetitive sequence of similar elements when they are arranged in the increasing order of their atomic number. Now, as I said, the elements have been divided into, all the elements that we come across have been divided into different blocks as S, P, D and F block elements. S block elements are those elements in which the outermost are what we call as valence electrons enter into the s orbital, and their electronic configuration, the outer electronic configuration is ns1 to 2, where n is the principal quantum number. There are two groups dedicated to S block elements. Group 1, also known as alkali metals, they consist of lithium, sodium, potassium, rubidium, cesium and francium. Group 2 are alkali earth metals, wherein we have beryllium, magnesium, calcium, barium, strontium and radium. P block elements are those elements in which the outermost valence electrons, outermost or the valence electrons enter the p orbital. The outer electronic configuration is n is to np1 to 6, where n is the principal quantum number. The groups 13 to 18th, including all others, they belong to this particular p block elements. Before going into the details, we need to know certain periodic properties. These are the properties of all the elements which will be repeated, and there will be a certain trend observed either across the period or down the group. These properties are atomic radii, ionic radii, and then we also study about ionization energy, electron affinity and electronegativity. Right now, let us understand the meaning of atomic radii. It is the distance between the center of the nucleus and the outermost shell containing the electrons, and it is also defined as the distance from the center of the nucleus to the point up to which probability of finding the electron is maximum. There are different types in this. One is known as the covalent radius and the other one is known as the van der Waals radius. The variation or the trend of atomic radii in the periodic table is, as you go across the period it will increase and down the group it will decrease. As I said, there are different types of atomic radii. The first one is covalent radius. It is defined as one half of the internuclear distance between the two atoms of the same element bonded by a single covalent bond. I have depicted a simple diatomic molecule here, wherein A and B comprises the centers of those atoms. The covalent radius is equal to AB divided by 2. Van der Waals radius is defined as one half of the distance between the nuclei of two adjacent identical atoms. Please note this. This is for the two adjacent identical atoms belonging to two neighboring molecules of an element, and this is in solid state. Now you can see two atoms here. This is two molecules here. This is one atom of this molecule and this is the other atom of this particular molecule. When they are almost closer, here a lot of other factors will come in. Here if you take this, what we call as electrostatic repulsion or other factor also comes in. Hence this is the distance from here to here, x and y. Now the van der Waals radius is xy divided by 2. Another property that we have to study is ionic size. We all know ions are obtained either by the addition or the removal of the electrons. Now we are going to talk about either the positive ions or the negative ions, otherwise also known as the cations and the anions. Definition of ionic size is it is the effective distance from the center of the nucleus of an ion up to which the nucleus exerts its influence on its electron cloud. Now interionic distance. So if you imagine a molecule to be made up of ions, the interionic distance is given by the sum of the R plus and R minus, where R plus and R minus are the cationic and anionic radii respectively. Okay, now here we have given different ions, both positive and negative ions, their atomic numbers, nuclear charge and the radius. We have 3 anions and 2 cations. Okay, and these are the ionic radii of each one of them. Now radii of the cation. When the ions are formed either by the loss or gain of electrons, cation is formed when a neutral atom loses one or more electrons. So we get the positive charge on the cation. Removal of the outer electrons makes the number of positive charges in the nucleus greater than the number of electrons. Hence what happens? The effective nuclear charge increases. Then what happens? The remaining electrons are strongly attracted by the nucleus and the electron cloud contracts. It will shrink, it will reduce. This tends to decrease the size of the cation. There is a reason why cations are smaller in size. So please remember, cations are always smaller than the neutral atoms. Examples here are lithium and the lithium ion, lithium cation, sodium and sodium cation. You can see here lithium is 134. This is the atomic radii and this is the ionic radii of this lithium cation. Similarly for sodium, 154 picometers. This is the unit used here. And we can see that the sodium ion, the cation, is smaller in size compared to the neutral atom. So the bottom line is higher the positive charge on the cation. As the positive charge goes on increasing, the size of the cation goes on decreasing. Smaller will be the size. Let's come to the next thing here. Radii of the anion. Anion is a negative ion when it is added with extra electrons. One or more electrons, an anion will be formed. Hence it carries a negative charge. Addition of the electrons to the outermost shell of an atom, it increases the net negative charge. So what happens? The net negative charge is increasing. Hence the nuclear force of attraction on the electrons decreases, because of which the effective nuclear charge also decreases. Hence the electron cloud will expand now. Whereas in case of cation we had seen that it was shrinking, because of which anion is always greater than the size of the anion is always greater than its neutral atom. We can have a look at this one. We have two examples here. We have fluorine, wherein which is an electronegative atom. It can take up an extra electron to give the fluoride ion. Similarly, chlorine forms the chloride ion by taking an electron. You can see that in case of fluorine, the atomic radius is 72 picometers, whereas fluoride ion is 136 picometers. Similarly, chlorine atom is 99 picometers and chloride ion is 181 picometers. As in case of cation, here the negative charge as it goes on increases, the size also goes on increasing. Okay. So this we have to remember. So I have referred some books for this one. So it is textbook of inorganic chemistry, Tuli Madan Basu, and physical chemistry. It gives quite an information about this. In the next video, we'll study few more periodic properties. Thank you.